Okay, now we are recording. Don't worry, I'll edit the first part. But João, answering your question, you have the notebook with this code already. The only difference that you might have is that you might have different variables in different places now, depending on how we choose. So, but if you want to do it yourself, so from the beginning as well, I can share it with you. Well, well, right now we don't have a lot of code, but I will later share it with you on the chat room, okay? Okay. So, but as I was saying, now we need to choose where to put the variables. So we want to have a decent and a clear storytelling in terms of visualization. So looking at the data set itself and the column names, what do you think the X variable should be? So what story do you want to tell? So do you want to first correlate in terms of X or Y, the model year versus acceleration, horsepower versus acceleration? That seems a very linear or a very strong possibility. What do you think? In terms of a data set, what visualization would make sense to you? So I'm free to suggest suggestions right now. Year maybe on the X, okay. So firstly, we want to compare the year with what? So let's just. So what makes sense to you? So probably what do horsepower versus, okay. More data. So don't forget, we are only seeing some call, but we have 400 car models. So in terms of year, it's probably, I think this is ordered from the 1970 to 1982. So we probably might have enough data. So, but horsepower versus weight seems as well a very decent or very good comparison. So not having more suggestions for now, let's just do it. So as for the X, I might put weight, right? Don't forget it needs to be exactly the same or else it will print out an error. For a while, let's put horsepower. So ignoring these seemingly not very useful variables, what would you put for the size marker, which will be noticeable? The size of the marker, sorry. Let me just put it so you can see them all, okay. What is the range? The range of what? Okay. The size of the marker. Okay, we already have horsepower, but the size of the marker, cylinders for size. Okay. Okay, that might do. So okay, there's a lot of suggestions. That's good. So let's just go with it so we don't get stuck too much on here. So for size, let's have cylinders. We can have the Y and size with horsepower, right? Yeah, we can, but that might make sense as well, but we would be losing a possible way of encoding another variable there. But yes, that's a possibility. So Danielle, your question was, what's the range of the size of the marker? So normally you would need to test that out in terms of how does it change? So I don't know. You don't know the size. For example, the years go from 70 to 82, a numerical value. I don't know what 70 represents directly. So probably when you put 70 there, it will be a very big ball in terms of marker, and you might need to divide it by 10. So it is from 7 to 8.2. Maybe you'll need to do somewhat of a normalization of the variable itself for the size. So don't worry about that. It's a trial and error because it depends also on the size of the screen or the size of the the size of the visualization itself. If it's a very small visualization, you might want to increase the size, maintaining the proportionality between values. Sorry. So, but we already have a pretty decent range of variables. So for color of the marker, it should be a fairly categorical value, don't you think? So it is very easily distinguishable. So we lost some we haven't used some very important, so miles per gallon and displacement. So we already have cylinders, horsepower, what you can have year per, okay. So let's use year. So, and for these smaller, let's use the two remaining ones, which is miles per gallon and displacement. So with, we'll use MPG. And for the line color, we'll use displacement. So yeah, model year, right? So we simply allocated the columns to whatever names we gave them, right? So now we can build the figure itself or a trace. So this will be a scatter, don't forget about it. So, okay, as any visualization, let's call it data 2D. You might already imagine what will be next, but firstly, the type of the data, which is a scatter. What? Okay. Why is it doing this? Okay. So we have an X, a Y. I don't know why this keeps popping out, but never mind. Which are the, okay, we have the name. And now we have size of the marker, color of the marker. I don't know if you remember from last class, but we had the marker option, which had inside of it size and color. These were one of the options that we saw. So the size will be size marker. And the color will be color marker. So I'm only separating all of this by paragraph, so it is easier to read. In terms of code, is exactly the same as if it was a straight line. So we already have marker, which has size and color encoded. So, and now we need to encode the marker line width and the marker line color. So for that, we need to go inside of the, that's why I was calling it line before. Inside of the line option, when it is uniquely in mode markers that we have to define later. Remember, the mode can either be marker, line, or text. When it is in mode equal to marker, which means dots, the line option defines the line that borders the dots themselves. So the line we have color and width. So color will be, let me just copy it, marker line color. And for the width, we'll have the marker. Oh, okay. I copied it wrong, but so this is color, right? So in terms of X, Y, we have the name, we have the color marker, we have the size marker, and we have everything here, right? So let me just tidy this up. Now we need to define the mode equal to marker, probably by pre-definition it already is in mode equal to marker, but nevertheless, let's assert that. And I believe that we have it all. Yeah, another thing, so since we have two color encodings, we can define their color scale, right? I don't know if you remember, we've done that with the heat map. So for the color scale of the markers themselves, the option does not need to be inside of the marker variables. So let's put viridish, so it is the same as the example. Don't forget the commas. For the lines, the color scale is inside of this option. So these are particularities. These are just some options you could fairly easily find inside of the figure gallery, not gallery, figure reference, exactly. I don't know if you remember from last class, but when in doubt, you go there. You just need to type whatever you're trying to find, and it will fairly easily get you there. So color scale option. For this one, we'll use the infernal one. So we have marker, name. Okay. So now let's just define a very simple layout. So let's call it layout 2D.
Professor.
Yeah.
Could you just explain us better what is the part of the color scale? You are defining a color scale for the marker and then another color scale for the line. Is that it?
Yes, no. Exactly. So since we have two color encodings, one for the marker itself, which is the color of the dots, and the other for the lines. So the border, you'll see the border of the dots themselves. It is optional. It is not mandatory. By default, it will have I don't know which color scale comes by default, but it differentiates the colors on a certain grid, right? And there's a lot of possible grids. So from yellow to black, from greens to yellows, etc. And here we are
okay.
Okay. Yeah.
Just to ask, I heard that you explained, but I didn't get it. Why do you put the color scale inside the dictionary in the line, but on the marker you put outside the line, the dictionary? Sorry.
That's just, yeah. Normally it should be inside of the marker as well, but it's just a quirk, so to speak. So
okay.
It's just how it is. There's no real reason behind it.
Okay.
Yeah. But by default, it has a given color scale, but here we're just overwriting with some color scale of our choosing. So did I answer your question?
Yes, you did.
Okay.
Thank you.
So it has a color. It needs to have a color scale. So a certain grid from red to yellow, whatever, and it brings one by default. But we're just using another one. And I don't know if you remember from last class, but there was a big option of color scales available. We'll go through them again. So, but let's just go to the layout. So it's a dictionary. We'll just define a title and an X and a Y axis. So title has the option text, which is the title itself. Let's call it 2D visualization. Yeah, let's call it 2D visualization.
No entiendo lo que dice él.
Sorry. Okay. So y-axis now, X. Let's start with X. So has a dictionary where we have the title option. For the X, chosen weight, and for the Y horsepower. So weight, horsepower. Sorry. So we need to put it inside of something, right? So title equal to horsepower. So if we didn't make any mistakes, now the figure, so fig 2D, should render just fine with all of the options we've chosen. So data equals to data 2D, and layout equals to layout 2D, right? We are just left with showing the figure itself. So 2D dot show. Oh, so color property is a color and may be specified as. Color size color. Which one was it? Color. The color property is a color and may be specified as such. And it received the displacement. So for displacement, we gave it to the line. So we've put it inside of the line dictionary. And it is inside of the. Oh, apparently we can't. Oh, okay. So for now, let's just move on and remove this encoding in particular. And again, width part is a number and may be specified as. So apparently I don't know how to write width. So line this, mark a line. So why is this exactly the same? Is a number and may be specified as. So again, oh, color bar, color scale. Oh, let's just remove this line option. Marker, lines marker, plus. Okay. Marker. Oh, it's markers. Oh. So apparently every mistake I could make was done here, which is kind of weird. Developer set to color scale. So color bar, color scale. You are exactly right, my friend, in terms of why it isn't inside of it is inside of the marker. So after all of this, it should be fine. Exactly, yeah. So okay, you don't have the because I have the zoom option bars here, but you don't see it, right? So after all of this hassle, actually there were a lot of mistakes, right? But I should have gone through them slower because it's a good learning opportunity in terms of debugging some problems you might have when you make mistakes. So actually I gave you a pretty good example of all of the possible errors apparently. But the good thing of this is that whenever you make a mistake, I did it too fast, I'm sorry, but whenever you make a mistake, the debugging, the error that prints out gives you exactly what you did wrong. So I could quickly, although there were a lot of them, I could quickly go through them and solve them, right? So that's actually a good plus in terms of possibilities. But I remember your question going for the range of the size. As you might see, the size is very small. So what we can do here is maybe increase the size of the dots of the markers themselves, right? So to do that, you simply need to add the higher values to the size while maintaining their proportion with each other. So the size marker was the number of cylinders. So if you go here, it is a numerical value that goes probably between 4 and 8. Maybe they are not ordered, but we get somewhat of a grasp of the cylinders distribution. If you want to understand more, we could go here. Actually, let's do that, to the histogram, and just see the histogram of the cylinders themselves, so we can get a grasp of the numbers that are here. So cylinders, let's change the name of the title. So the cylinders go from 3 to 8, right? So if we want bigger values, we probably need to multiply it by, let's say, 10, so that the smallest point, which probably are these ones, are 10 times bigger. Maybe 10 times bigger is excessive, but let's try them out. So it is as simple as going here to the size of the marker and doing it times 10. So it multiplies every value of the size marker by 10. And if you run it again, okay, yeah, as you might understand, 10 is too big. So let's do a smaller value, like 5. What do you think? Is it too big? Yeah, probably. Let's do 1.5. Do you think it's an appropriate size? Let's, yeah.
Yes.
Okay. So, but let's. Oh, sorry. Yeah.
Can I just have when we see on the graph, when you hover over a point,
yeah,
does it impact that point? Meaning that now if we see the cylinders somewhere in here, no, we can't see the cylinders when we hover over the point. Does it impact, meaning that the point would show the value multiplied or not?
Yeah, it would. That's an issue.
Okay. Okay.
There's a way to go through that. So there's another option that we can put here, which is, I don't know if it's called metadata or hidden data, something like that, which is information that you store inside of a trace that is not used for the visualization itself, but later on, will be used for the hover. So instead of choosing the size of the marker for the hover template that will go later, you would choose that information that would be the correct value of the cylinders. But we can do that after we introduce what the hover template is, right? So, but we still have a problem that I missed. So I didn't manage here to introduce the marker line width and the marker line color. As if you go to the examples, you know that at least the line width, it's a possibility. So, and I honestly don't know why I missed it, but let's try once again to input the line width here. So I'm actually copying it from the example I gave you so that I make no mistakes this time. So we are using different variables than from the example, but the result should be equivalent. Line is inside the markers as well, I think. Oh, it is, yeah. Oh, thank you. I would make the same mistake again. So as your colleague told us, and very nicely, this line option is inside of the markers. So right here. So let's take a moment. So inside of the markers, we have size. We've chosen a color scale, which I previously put wrong outside of the marker. We've chosen a color encoding. Okay, and we've chosen now the line of the markers. So this was a big mistake on my part because, as you might remember from last class, you can have the marker variable, which goes for the points themselves. You have the line variable, that would be for the lines themselves. And you actually have the text variable, which we already have here defined. So, but for now, this is enough. And as you understand, the line is probably defined to white, and it has a very large size. So the line width was the MPG, and the MPG ranges from maybe 18 to 31, and it is very big. So if we come here and we now divide it, for example, by 10, hoping that it's not too much, we will have the width, well, 10 times smaller. So here we have it. Apparently, the less weight it has, the bigger the miles per gallon there are, so it makes sense, right? The only issue here with both the sizes, so both the size of the markers themselves and the size of the border, is that in terms of understanding, it gets really hard to distinguish between what is the size, at least in terms of first impression. But here we have a clear view that the smaller the weight of a vehicle is, the higher its miles per gallon, the higher the miles per gallon it has. So, and that's intuitively true. So, but now moving on and going into what your colleague asked on the microphone. So if we hover over a point, it only tells us the model of the car. So which was the variable defined in text, right? So, but imagine that you wanted to show every value. So we have here we have 6 values encoded. Imagine that you wanted, whenever you have your mouse on top of a point, to show all of those values. So by default, when you hover over a point, it shows you the text, but actually you can control whatever it's shown with the hover template variable. It's not an issue, but the hover template, it's encoded in HTML. So if you want to, for example, use a bold, put a paragraph or something else, it needs to be an HTML. So, but we'll go through some basic HTML options. So let's say the first variable that we want is the car's name. So we want to show car's name and then the name of the car. To show a particular variable, you need to put it in like this. So in percentage and inside these curly brackets, right? So we want the text variable. What this does is car's name and then the particular name of the car. So let's just run it as it is. So if you see that, if you remember from the last example, it showed the X and the Y without any text before. Now it only has car's name and the name of the car. But imagine you wanted the car's name to be in bold, which is an HTML command. So you could easily find that on Google, but for example, to bold, it needs to be inside, of this. So whatever text value is inside of these brackets B, brackets dash B will be in bold. So if you run it again, now we have the name of the car in bold. So, but since we don't want line is okay, since we don't want every variable to be inside of in the same line, we need to use a paragraph or a break. So that's another HTML command, which is called br. So as you already, let's use 2 paragraphs. As you can already see, they have a similar structure. So let's just use paragraphs so we can distinguish, but this is the same string. So the paragraphs that we use here do not have impact on the string itself. This is just for us to have a better grasp. Now we want to have the X value, for example. Let's use the weight. So weight. Okay, it needs to be. So this is the same string, but we are just visualizing. This is just to help us. Normally, what we should do is, sorry, let me just. So this is this Hoover template accepts a single string. So what we should do is now like put weight, etc. But to help us see since we want to to put every one of those 6 variables here, it would be a very long line, as you might imagine. Since we want to make it easier for the reader to see it, this is just for us to see the code in a clearer manner. We'll put it like this. So string, when you put a plus sign between 2 strings, it automatically merges them. So plus sign, and now we can do a paragraph, and the strings will be merged into a single one. So this is equivalent to having everything in the same line and in the same parentheses. So continuing, now we want the weight. We should put car's weight, but again, percentage, curly brackets, and the name of the variable. So the weight is encoded in the X, right? Yeah, so this is the X. So let's just do this quickly for every one of them. So the Y is the horsepower. So again, horsepower will showcase as the Y. Plus, so we merge the string again. Oh, this keeps popping out. So what do you say we put next? So now we want the size of the marker, which is the cylinders. So cylinder. Let's put the asterisk for number, cylinder number. So now we have an issue because this variable is encoded inside of marker and inside of size. So if we were to put just size inside of the curly brackets, it would print out a mistake, so it wouldn't find it. In order to access the variable size so it prints out, you need to put the path to it. So marker, and the path is defined. We go inside it by putting an underscore, right? So marker underscore size. So this is how we access the size inside of the marker, which represents the number of cylinders. Did everyone understand this part? So let's do for the, oh, that's cylinder number. That's just me typing, don't worry. Okay, moving on. So now we want to encode the model here, which is,
I,
sorry, yeah.
I just didn't understand the percentage sign. What does it mean? I have some freezes on the connection, but I believe that it's my side. I don't know if it's happening for everyone else. And
Sorry,
sometimes I
sorry.
miss what you say.
Oh, there's freezes on my voice?
Yes, but I don't think if it's only on my side or not. But
On my
sometimes I
side, there
miss what you
isn't.
say. There isn't? Okay, so it's my
No.
side.
I'm actually
What's
connected by cable, but yeah.
Yeah, me too. I don't understand.
Okay.
What's the percentage sign?
Oh, this is just so we can differentiate what is a string. So this is
Okay, the
a
variable.
static variable, and this is the one we want to access. So if we want to access the x variable, it is percentage and then curly brackets.
Okay.
That's by definition. So the only thing you need to have into consideration here is that to access a variable, it is percentage curly brackets, and to access variables that are inside of dictionaries, so sub variables, you need to put the full path, separating them by an underscore. So for example, the cylinders is this size variable, which is inside of marker, so marker underscore size. We'll do the same now for color, which will be marker underscore color. So the year, it's the year, right? Yeah. The year is the percentage curly brackets marker under size color, and the other variable, which is miles per gallon, which unfortunately will print out normalized, so to speak, or transformed, will be printed out here. Will be, okay, let me just type miles per gallon. Will be inside of a line and inside of marker. So marker underscore line underscore width. So again, percentage curly brackets. So marker underscore line underscore width. Width. Okay. So okay. So I can already see something that is going to go wrong because we forgot, but let's just run it. So if I hover over it, because I forgot the paragraph, what you'll see is that car's name and then no paragraphs separating it. And something is not, oh, it is not undersized, it is dot, sorry. So not undersized, it is the dot that allows you to access inside of marker that variable, sorry. So, and as we said, let's put a paragraph separating each of the variables. Is it possible to divide the MPG by 10? No, it is not possible. Yeah. Since it is not a static variable, you can't do it, yeah. So now, so yeah, the hashtag really does not seem all right there. So let's change it to number. Yeah. But now with little to no effort, we have a pretty slick in terms of visualization, right? So we only have an issue here, which is, as you might see, trace 0. That's because we did not define the name of the trace, and by definition, we will put trace 0, trace 1 if there was more than 1, and so on. So for this, remember the trace number, the trace name is the legend itself. So there's an option which is show legend, show legend. That is either true or false. By definition, it is true. Let's set it to false. Let's not forget to put a comma here. Let's just believe it is show legend. Did I type it wrong? So, for example, I made a mistake. Show legend. There's a typo, right? So, but again, this is a very good learning opportunity because whenever you have something wrong, it shows you exactly what you have wrong, which in terms of getting it right, it's very quick legend. Thank you. Yeah. So now there's still trace. Scatter visualization. So apparently we can't. Yeah, we really need to define a name for this. So name scatter visualization. So quickly, yeah, exactly. If we wanted to get rid of the name, I'm sorry, it was not that option. It would be to make an empty name here, right? So yeah. So the show legend apparently in reality is just when you have multiple traces and then you don't want them to appear on your left or right side. By default it appears on your right side and you don't want them to appear, so people can toggle them on and off. So when you don't want the trace 0 or whatever name you chose there, you just need to set name to nothing or to something you want, right? So, but you actually made a very good question. Whenever you have to normalize a variable, so it is better to visualize, you have a problem with the hover, right? So this, you actually normalize the MPG and the cylinders. We have the cylinders variables set to 1.5 size bigger, which is represented here as a wrong number. So actually it wouldn't be cylinder size equal to the cylinder number equal to 6, but it should be, well, a third less, right? It should be 4. So to change this, we could go, when you don't know, we could go to Plotly Python. You would go to the figure reference. We are on the scatter plot. You have name, visible, show legend. We have mode. There's a lot of them that you might remember. You have overtext. You have other hover possibilities. We've changed the template. So, but here it is. Assigns data each data. So there it is, the option that we were searching, custom data. So as you can read here, assigns extra data to each datum, so to each data point. This may be useful when, exactly. So this is what you want, custom data. It's not inside of anything. So you just need to come here. Let's put it below. Custom data. Now you need to have a new variable that is not normalized. So we can grab directly the df cylinders. And if you were to put it in the hover template, so instead of using the marker.size, which is changed so it is better visualized in terms of size, you could use the custom data. So I believe this should, exactly. So remember, the cylinder number was 6, now it is 4, which is the real number. So the only issue that persists is the miles per gallon that is also normalized. So to do that, I believe there's also another possibility in terms of custom data, but for now, let's just leave it as that. So, but in reality, we weren't able to use all of the variables. Imagine that you wanted to showcase a different variable. Imagine that you wanted to do a 3D plot. Well, in terms of in terms of differences between a 2D scatter plot and a 3D scatter plot, there aren't many, and we can easily change it. So now we just need to add a new variable. So since I failed to encode the
Sorry,
display,
Professor.
yeah,
Can we go back to the custom data?
yeah,
When you define the custom data, you define it. I don't know if it doesn't matter actually, because you defined it after the Hoover template,
yeah,
and it still is able to read before. I don't
yeah,
know.
it makes no difference because since it is inside of an object, it does not read it by order. So it first
Okay.
compiles a data dictionary, which has all of these options, and then he renders it inside of the figure. So it
Okay.
doesn't make any difference in terms of order what is inside of the data object.
My second question would
Yeah.
be, you went to the Plotly reference guide and you understood that the custom data should be implemented in this way, but actually in the future we might have these kinds of difficulties and we
Yeah.
should go to the reference guide. I don't know if it's possible
Uh, I
you read the reference guide and you interpret that the custom data should be added in. I don't know if it's something that it's explainable or not, but
okay. I'm not
I don't know
quite.
if I made myself clear.
Yeah, I don't know if I quite. So yeah, custom data is a kind of a particular thing that you might not get into. So if you had this question, so how do we encode more data inside of the data of the dictionary so that I could use it for the Hoover template? Yeah, sometimes you need to search it. So since we are inside of the scatter atmosphere, so to speak, there's only a limited amount of options. So there's a lot of them, but if you go down, you will eventually find them. And most of them you will easily distinguish if they have nothing to do with what you're looking for, or they might help you. So sometimes when you don't have a particular thing, that when you, for example, control F and search, or there is a search option on top, when you don't find it at first because it might have a particular name, you might, well, you might need to get into here and just read some of them and try to make sense of it. So, but in particular, most of the data, most of the options will not make sense to you. For example, if you're reading this in trying to search the custom data, you probably would see, oh, meta, so number or categorical coordinate string. So for example, maybe this one would also be able to be used for the Hoover. Probably not, because it's not saying here, well, in terms of custom data, it uh, it specifically says that can be used in Hoover. But if you were to be searching, most of them would not make sense to you, and you would quickly go through them and find whatever you're looking for. Also, if this doesn't work, and probably your first option should be that, is just type it in Google, and probably someone already had that problem and it was solved. So between Googling it and going to the references, that's the answer there. Did I answer? Sorry, I kind of went on.
yes, I'm having some freezes. I might need to restart. What I mean is like when you look at the Hoover template, you see that it has a lot of information,
Yeah.
and that information is transcribed in what you showed us. So what I mean is like I guess this is a trial and error, and
I'm not hearing you right now.
but
Okay.
seeing, are you listening?
Yeah, I'm.
seeing what it's written here in the reference guide relating to Hoover template, I wouldn't directly implement what you did in Python. That's actually what I mean, but I believe that is from experience and you start to gain it as you work with it. I don't know.
Yeah. When you, for the basic thing, for example, the Hoover template, it's not basic, but it's something that's really useful. So, but there are things that maybe you'll only need to use once. And in those cases, maybe the references won't be enough to understand how to do it, but you can always Google it in the end, and probably someone has already done it. But yeah, for those more quirky things or harder to find options, yeah, you
Okay.
need to search for them. Yeah.
Okay. Thank you.
Okay. Um, moving on. So we were starting now with the 3D visualization, right? So the change is fairly simple, but first of all, we need to have a variable to encode in the z-axis, right? And since we didn't manage to encode the displacement, let's use it as our variable for the z-axis. So we already have it ran. So to change a scatter to a scatter 3D it's as simple as defining a new type, scatter 3D. These variables are all the same, so we still have an X, we still have a Y, we still have the markers, etc. We will still have a Hoover template, so all of the variables that you used until now are the same for the scatter 3D. We simply need to add our Z variable, so Z equal to Z. Let's just change the name. So in terms of the trace of type scatter 3D, there's not many changes or different changes that need to be done here. So that's right. The only change when going to 3D is the layout itself. So now we have a new axis. But giving you a brief explanation on this, the 3D figures and the 2D figures in terms of plotly rendering are fairly different because they are of a different spec. We'll go through the spec variable later, so just keep in mind that word. But the way it renders, it's fairly different, and the axes themselves are defined in a different way when going to 3D. So the title itself, in terms of layout, maintains the same way, but the X and the Y axis are not defined in the same way. So they need to be encoded differently. Let's just take them off for now. So our layout 3D will have a title 3D visualization, and we'll need to add a new label for the Z axis as well. And for this particular visualization of a higher dimension domain, so 3D domain, we encode the Y, Z, and X axis names or labels inside of the scene variables. So scene equals to dict. So inside of the dictionary, we'll have the X axis, sorry, which now will be done the same way. But keep in mind when going to 3D, all of the axes layout options need to be inside of scene. And that's really important. It will print out an error, but you'll know how to solve it then. So again, x-axis title. The title was weight. So it keeps popping up. The y-axis, again, dictionary title equals to horsepower. And now we have the z-axis. Again, dictionary title equals to, now we have displacement. So This is just for visualization's purpose, code visualization purpose, so don't worry. So now, since we didn't make a new one, we only changed the name, let's just change it here as well. So 3D. So on the axis, thank you, title. So, and if I didn't miss anything here, we should have, okay, so I missed a comma. The width property is the number that may be specified. Okay, this is a good learning opportunity. So I told you that nothing changed. Apparently something changed. So invalid value of type, remember this is a column, a series, received for width property. So apparently the scatter 3D marker line does not have width property, so we cannot encode it here. So, and also in the example, I did not encode it. So for now, let's just take it off and give it, if you go here, it needs to be, the width needs to be a float or which means it needs to be a numerical value higher than 0. So now when you go to 3D, you can't encode. If you think about it, it makes a lot of sense, right? Because if you had, now we have a ball instead of a circle, and if you had a border, you wouldn't, if you had a border, you wouldn't see the color of the marker itself, and you wouldn't see the size of the marker because you wouldn't see a border. You couldn't distinguish between the width of the border and the size of the marker. So obviously this is not an option right now, so we can just delete it. So, and now we lose an encoding, which was the miles per gallon. Don't forget to take it off of here, of the Hoover template. We can actually already replace it with the Z, right? So displacement. So we've removed the line width and we've changed it in terms of Hoover template to Z. So let's run it. And here we have it. So as you can see, it is fully interactive, so to speak. And if we hover over some of the points, we have the displacement down below, right? So well, 3D is probably not the best option, but in terms of understanding the data, you can already see that the weight and displacement, as we already seen above or in the previous visualization, have a correlation, fairly linear. If we change this a bit, the horsepower and the displacement also have a relationship, fairly skewed, but a relationship nonetheless, and so on. So when you go 3D, you get the possibility of understanding other relationships between one more variable, but it needs to be interactive, right? If this was a static visualization, it would be very difficult. Well, it wouldn't be impossible, but it would be very difficult to understand the relationships between all of the 3 variables that we have here in terms of axes, right? So this, for now, in particular, are the scatter or multiple encoding examples that I have. Do you have any doubts in terms of multiple variable encoding for these particular examples? So I will assume that not. So moving on, since we only have we still have half an hour left. Okay, yep, there's no dot, okay. So we still have half an hour left, but yeah, we can go through that. Yeah, we have enough time. So the other example I wanted to give you is Subplots. So, and do you have, okay, as in, it is not, do we have access to those exercises as in the other courses where the teacher gives a documented answer and it's not coding?
I mean, for me, it's kind of difficult to follow up because I don't have the lesson, or I don't have the exercise in my hands. So I'm just seeing you coding.
Yeah.
And for me, it's kind of difficult just saying that because I have to do my own, I have to do my own comments.
Yeah.
So it's kind of difficult in this moment to follow up. And
Okay.
in other courses, the teachers gave us like the Python file with all the comments and the exercise, so
Yeah.
we can follow through what they say, because sometimes we have doubts, like when we are doing our final what's the name, or final projects,
Yeah.
and we can go back to those exercises and see what he was doing.
Yeah,
I don't know if they're gonna have access to the exercises.
But the notebook is already on Moodle.
But is this notebook like
Yes.
the one that you are coding?
Yeah.
Right now.
Yeah, the only difference in this particular notebook is that we've encoded differently. So I believe we had displacement here, but in terms of code, it's exactly the same.
Okay.
Did you download and uploaded it to Colab?
Yes, I do.
Yeah.
Wait, doesn't matter. Follow.
But did you see the code?
Yeah. I'm saying, but it's kind of. I have to put my own comments because I don't know what is next. You know.
I'm not quite understanding what your question is here. Sorry.
So no, continue. I will give you my feedback later.
Okay. Yeah. Okay. We can. Okay. There's no issue. Okay, but moving on. So in terms of multiple encoding or encoding multiple variables in a single visualization, well, we've already gone through that. But now I wanted to introduce you to subplots. So inside of the same visualization, having multiple plots, right? So imagine we wanted to have a 3D graph and the 2D graph inside of the same rendering or the same figure. For that, we will not use the go.figure object. We will use them, but they will be part of the subplots. We'll have to import from plotly.subplots, import the make subplots function. What this function does is basically a wrapper where you introduce the already built-in go.figures, and it simply renders it as a multiple as a subplot, right? So giving a small example, so we already have the Fig 2D and the Fig 3D. So although I've overwritten the code, it is still here. So if I try to render the Fig 2D, we still have it, although I've reused the code, we still have it saved inside of this variable Fig 2D. So let's try to make a. We have always to type the code first. Yes, inside of, for example, we are using a notebook, but if we were using a script, so a normal text file that would be ran in Python, you would also need to import it. Yes. The only difference is that while in the notebook, while we still are in the same session, so we haven't restarted anything, it maintains it. So that's the only difference. It uses the same library for the other cells. You can use it in other cells, sorry. So, but moving on. So the make subplots function, function defines a figure. So for our titles, so let's define a new variable. We have the 2D, and I'll call it 3D. So we can keep the titles. Sorry, so we can keep the titles simple. Titles. So, and as for this, we'll call it fig subplot. This will not be a go.figure object, but will be a make subplots object. So make subplots. First of all, you need to define how many rows and how many columns you will have. So thinking in terms of a grid, we will, for this particular example, we will just stack them vertically, so it won't have any columns. So columns or cols equals to 1, and we'll have 2 rows, 1 for each of the visualization. And since we have, since we have visualizations of different specs, I don't know if you remember me saying it. So we have one of 2D of a 2D kind, and we have another of specs 3D, right? We need to define them, or else we'll have an error. So this is still confusing, but let me just define this first so I can explain it to you. So the specs variable here, which is necessary whenever you have something, a subplot different from the X and Y kind, so from the 2D kind, you need to define its type here, so it knows how to render it. So again, it will be a matrix or a table of the same form of how you defined it, sorry. So for example, if we have 1 column and 2 rows, we'll have, in terms of specs, an array with 2 entries, 1 entry for each row, where each entry will only have one of the definitions. So for our first plot, the one that will come first or on top, will have an X and Y type. And for the other one, it will be of type scene. Let me see if I do this. Yeah. Actually, you need to define it inside of a dictionary. This is something very particular to the subplots options. So there's not really a way around it. So a dictionary needs to have a key and a value. So the value is X and Y, and the type is of X, and the type is the key itself. So dictionary again of type scene. So now that we have this written, let's just go over it again. We first define the number of columns, which is 1, since we don't want anything stacked horizontally, and the number of rows, which is 2 in this case. So we have 2 visualizations, one on top of the other. After that, since they are of different kinds, so one is 3D and the other is 2D, we need to specify that so it knows how to render it. This is the specs option. You need to give it an array of the same structure of what you defined here. So as you can see, each column only has 1 value, which represents cols equals to 1, and we have two rows. So this is, in terms of visualization, this is only to help you understand, but this is how to do it. For example, if you had 2 columns here, we don't have another figure to put it in, you would simply need to add it in this particular place. So it would have two values inside of this subarray, which represents the number of columns. So, but changing this to our particular case, we have to define the columns, the rows, and the specs. And here we can already input the subplot title option, which is inside of the variable titles. Naturally, it will have to be of the same size of the number of visualizations defined here, which is columns times rows. And so we make a blank figure, so to speak, which has two entries, one for each row, of predefined types, one of 2D type defined by XY, and the other of 3D type defined by scene, and it already has some titles. What we need to do now is introduce the traces or the figures inside of each place. So for this particular purpose, we need to add some traces. So fig underscore subplot dot add traces. Add trace, sorry. For the first row, we will use the 2D fig. If you go up here, it's fig 2D, sorry. Fig underscore 2D. And you need to allocate it in the place that you want. So we want it in row equal to 1 and column equal to 1 as well. And for the 3D is basically the same place, the same thing, but for a different row. So we add the trace for the 2D here and the trace for the 3D here. So changing and want it to be in row 2. The only thing left now is update the axis. So remember, this doesn't have any layout yet. Oh, data. So, sorry, this is data. So we do not introduce a graph object, we introduce a dictionary of type 2D scatter here and a dictionary of type scatter 3D here. So there is no layout here yet. So if you render it as it is, for example, we would need to, actually we don't need to build it anymore because we already built it from the beginning, right? So we just need to show it. This is simply subplot titles. Okay, it needs to have an S here. So if we build it as it is, we currently see that we have the 2D on the first row and the 3D data on the third row. If you notice the difference, there is no layout here because we did not introduce figures, we introduced the data itself. So this is not the figure 2D, it is the data of the figure. So what we need to do now is introduce the layouts in the particular traces. To do that, we don't do it not in the normal way since we already built the figure. We kind of do it on the opposite order now. So we built a figure without any traces or layout. Then we've added the traces or data, as you might, and now we need to add the layout. So we want the axis for the 2D visualization, and we want the axis for the 3D as well. If you remember, the axis for the 3D visualization were defined in a different way that we are used to. So to do this, we simply need to update them with this command. So fig subplot dot update axis. Update axis. So is it already here? So as you know, there's a lot, as you can see, there's already a lot of options here. So we can update the Y and the X axis. So let's start with the X axis. And this is very particular to subplots, so don't worry. Where the title is equal to, if you remember, the title of the X axis was the weight. and we'll do the same thing for the y-axis. Subplot dot update axis. This time we'll update the y-axis, and the title is horsepower. So horsepower. So now if we render this, we can already do it. We've only changed the axis of the 2D visualization, right? Right. So you might find it weird, but here we did not define where we've changed the axis, right? So if you might think that this would also update the axis of the 3D visualization, because we did not define where the row and the column were in terms of update. That's why we have this differentiation. So this particular command only affects the axis of the figures that are of the type XY. For example, if we had two figures of the type XY, which means two scatter figures, we would have an issue here, and we would have to apply a different command that would specify which row and column we would change the axis of, right? So, but now to change the axis of the 3D plot, it's a little bit different as well. So now we need to access it in the different way. So layout scene. Remember layout scene? I know it is kind of weird, but this is the way to do it. So it is better to have an example at hand. And now we just need to update. And as you can see, there's already these options, but let's update them as a whole. And now I'll just copy what we had here because it will be the same. So let's just repurpose what we have. Don't worry, I'll wait a bit. So what we're doing it here in a very quirky matter in terms of what we're used to is accessing the layout of the fixed subplot, and inside of that layout going inside of the scene, and then as we had defined previously, changing the X, the Y, and the Z axis. This again showcases the differences between, in terms of layout axis manipulation, of the 2D and the 3D plots. So unfortunately, since it is kind of weird in terms of what you're used to, this is the way to change it or to define it. So also there's kind of, so as you might notice by default this has a certain height and width. So in terms of width we are pretty well, but in terms of height this is pretty small. So let's change that as well. So a different way to update the layout is simply defining it as we know. So here we want a general title. So title equal to dictionary text equal to, again, this is always the same thing. Let's call the general title subplot. Subplot. So, and now let's change the height only. So height, yeah. And let's change it to 950. So normally this depends on, I believe this is the number of pixels. I'm not quite sure, but again, this is a trial and error process in terms of height and width. Since we are happy with the width itself, let's keep it with, yeah. So now if we height, why didn't it become bigger? Height. So again, let's increase it a little bit more. So 1500. Obviously, so we've only defined the layout, but we forgot to introduce it inside of the subplot itself. So obviously, right? So another way to update the layout is update. If you're inside of Collab, it already shows you the options, but you can see it here. And you can simply introduce your layout. So obviously this wasn't changing anything because we are only defining a dictionary and not introducing it into the subplot. So maybe now 1500 is kind of big, but we'll see. So if we render it, okay, it is so big that it doesn't even fit here. So I've completely, let's put it a smaller size. Okay, this is far better. So again, trial and error. Still the size is not optimal because it kind of, it depends on your zoom. But here you have an introduction to subplots. As you can see, all of the axes are well defined. Again, the only issue here is that in order to change the axes themselves, you might need to get into some different methods. So here we see different methods of updating the layout. So we have update axis, directly going into a particular axis. We have a way to update a particular variable, and we have a way to define a layout. Yes, you can. Yeah, we can do that as well. So, but here we have three ways. Just finishing up this part. Here we have three ways of changing the layout itself. So for the 2D axis, we have this way. For the 3D axis, we have this way. And for the general layout options, we have these ones. We could also use other layout options here, but for now, these are enough. As for your question, yes, you can. And it is defined when you do the subplot, when you define the make subplots option function itself. So actually let me see if I can get you the option here. So yeah, so this is one of those things that you would need to search, but it's a possibility. And the option is row heights, which will go, and we have call width. So column width. Okay, I'll just copy paste because I already had this option. Don't worry, this is in the example commented in the example that I gave you. So as for the row height, this is the only thing we can change here because since we only have one column, obviously it will have a fixed width, right? And what you introduce here is an array that has the same number of entries as the number of rows, and the sum of this array needs to be 1. So you define it proportionally. Explaining it in a better terms, right now, by default, it equally partitions every row. So if you imagine a whole visualization as having height 1 and width 1, here you partition the proportion of each row. So we have 2 rows where each row has a value of 0.5. If you wanted to have the first row with a higher proportion than the second one, you could do 0.6 and 0.4, for example. The number cannot exceed 1. I don't know if it prints out an error or simply distorts the visualization outside of itself, but this is the way to change it. For example, if you wanted the first row to be very small, for example, 0.2%, and the 3D plot to be very big, so 0.8 in terms of height, Here we don't have columns, so there's no use in using that variable, but it is equivalent in terms of how you define it. You do it like this. So ideally, the first row will be 20% of all of the height, and the second row will have 80% of all the height, as you can see here. So you just need to remember that you do not define in terms of numeric values, so not pixels, but in terms of proportion. So the sum of that array or of that set should always be 1. So yeah. So if you go to the notebook itself, so we only have 10 minutes actually, but if you go to the notebook itself, there's other subplot options. I'll stop sharing and now I'll change to the notebook. So, okay, it's here. So, let me just, okay. So you're all seeing a different notebook, right? Yeah, okay, thank you, yeah. So this is the example I gave you. It's kind of different. So, but the only difference are the visualizations encoding, and there's a color bar here. So, there's an issue with the color bars in Plotly when you subplot, but you can read all about it just so I can explain you what the rest of the notebook itself. So, if you go down, you'll find another subplot, but now with different kinds of plots. So we have a scatter plot, a bar plot, and a pie plot. So keep in mind the specs option. So the bar and the scatter are still X and Y in terms of type, but the pie is of type domain. So it's all commented, so don't worry. Here we have extra materials. Oh, this is actually different notebook. You have some exercises after this. So I want you to have it as homework. So you can make a subplot, actually 2 subplots of the exercises from the datasets provided by Professor Pedro Cabral. You already have the figures. The only thing you need to do is introduce them inside of the make_subplots function. Also, this is more trivia or something that you might want to use in the project. So don't worry about this. This is just for those of you who want to learn more and see all more possibilities. But there's these indicators, figures. There's also a compilation of them all. And then there's ways to do animations and to use sliders. So this is hidden. I don't know why. Okay. So again, the rest of the notebook is just a showcase of all of the options that you can use in terms of Plotly visualization. So this one has a slider below that changes the visualization itself. I don't know why this is, okay, this is very slow, and this is an animation. So if you click play, naturally. So as for this class, you have the exercises, but I was expecting to end a little bit earlier, so you had time to do the exercises here, but nonetheless, don't worry, next class we'll go through them. But if you want to try them at home, that would be even better. But if you don't have any question, that's it for today. Yeah, next lab I'll give you the solutions, and we'll do a quick review if any one of you has any doubts. So like this. Also, as for next class, we'll go to spatial data, so maps and all of those things. So yeah, just to give you an introduction, but that's all. Thank you. I hope you enjoyed this first at least my first of online class. But yeah, okay. Thank you very
Thank you.
much.
Thank you.
Thanks.
Thank you. As for those of you that I'll stay here for a bit more if anyone has any questions. So yeah.